The University of Georgia's ForgeDawgs proudly presents to you their American Felling Axe submission for the 2026 forging competition. For our axe, we initially decided to go for an asymmetrical wrap design for the main body of the head with a forge welded bit to the edge for greater hardness. To this end, we chose AISI 8620 for the body and 4340 for the edge, with 8620 being known for its overall toughness with an impact strength of about 120 joules, and 4340 being known for its hardness at about 53 rockball hardness. The process started with hammering out our 8620 to shape. Aiming for a 3.5 pound head, we started with 4.5 inches of 2-inch diameter steel bar after having both bars cut to length at our College of Engineering's machine shop. Variations to our initial plan began almost immediately. By selecting round bar, we were able to quickly determine the necessary volume for the desired mass, as well as to easily purchase our material as round bar was most abundantly available, but failed to consider that 2-inch thick metal would be resoundingly difficult to hammer out into a rectangle of about a 1/2 inch width, especially as we moved into this project with pretty minimal experience. I mean, look at this thing. After about 8 hours of work, we ended up with a cross-section of about 1.5 inches by 2.5 inches. We decided for the sake of time it would be much more efficient to simply just punch and drift what we've gotten to so far. And simultaneously, we worked on hammering out the 4340 to a flat bar, and as we started with only a 1-inch diameter steel bar here, this was much more manageable. To not get too far into the head without having an idea of where our handle was at, we switched gears and started working on the handle. This process was at first pretty straightforward. We started with 3/4 by 2.5 inch by 3 foot hickory lumber and used a bandsaw to cut the shape of the axe out, and then ran it through a table saw to cut off the extra width. An oscillating belt sander was used to smooth out the handle, and then 4 coats of linseed oil were applied to finish and protect the handle. Coming back to the head, the eye was punched out the rest of the way, and the angle at the front of the head was shaped. At this point, 2 big issues are realized. The drift that we have available to us is not as wide as the eye and the handle is. Although it initially expands the eye, it isn't nearly enough even after punching alongside the current eye and drifting the newly formed segment. This means the eye on the handle is sanded down to compensate. The second issue is the length. We initially read the specifications as no more than a 36-inch long handle, and as a result, the handle ended up at about 34.5 inches long, an inch too short for the minimum allowable length, 35.5 inches. To remedy this, the existing pommel was sanded flat, and the new wood, dark walnut, from one of the teammates' father's workshops, was grafted to the end and sanded to fit the overall shape. Moving forward, it was time to finish forging the head. After visiting the Office of Research's instrument repair shop and having a cut made on the narrowed end of the head as well as on the bit to prepare for forge welding, disaster struck. The footage of the forge weld attempt was unfortunately lost, but the footage of the aftermath is right here. We had neglected to consider the wildly varying structures between 4340 and 8620. As a result, forge welding wasn't just difficult, but nearly impossible at the skill level we entered this project with. This left the material jagged, cracked, and at one point entirely absent, where splitting the crack blew out part of the wedge, and ultimately not even welded together. It was decided we would have to forego the weld and just use the 8620 body. This was especially disappointing as 8620 had not been chosen for its hardness. We decided the best action moving forward was just to focus on repairing the damage from the botched weld, and instead of normalizing the 8620 and trying to aim for perlite microstructure for a tough body, we'd quench it in water for a martensitic microstructure to try to maintain at least some of the hardness. And it was, of course, after this, tempered in my kitchen oven for 2 cycles at 450 degrees Fahrenheit for 2 hours. From here, the head was fit to the handle by pushing a slot in the top of the eye and hammering in a wedge, and then properly finished, being buffed with an angle grinder, refined at the edge with a rasp, and finally being sharpened with a sharpening stone and honing oil. And that brings us to what you see here, a finished American felling axe ready for competition in the Forging Industry Educational and Research 2026 competition. Thank you all for watching, and go dogs!